Hello, this is Andrew Powell, and this is another demonstration video. And what we have here is the first prototype. There's going to be two more prototypes after this, but this first one here obviously does not really focus on looks at all, but it does focus on the tracking algorithm. The motors actually aren't connected, but the application that's running on the PIC32 right now depends on the two IR sensors on front. And what the application is doing, it's testing basically our control algorithm, which I first simulated in MATLAB, but I managed to implement it in C for the PIC32. So if you look closely here, if I put my hand in front of the one sensor, you notice that the theta degrees goes up, and if I put my hand in front of the second sensor, you should notice that the theta degrees drops down. If I remove my hand, it should basically center back to 0. I haven't really played or changed the coefficients of the PID controller that I'm using, so right now theta degrees does not go back to 0. Plus, on top of that, if you notice, I don't have my hand in front of any of the sensors, but the sensor 1, IR1, is always greater than IR0. I'll have to do some calibration basically to ensure that both sensors start out with values that are much closer to the same, but basically this test does what it needs to do, and it demonstrates that everything is working. This information is being posted like once every 2 seconds, but this algorithm is running 20 times a second basically, and process cycles basically indicates that. If you look at it, if you look where it says process cycles, that basically indicates that it takes 2 million cycles for the next iteration of the algorithm to execute, and that's dependent on the rate at which the values are being sampled from the IR sensors. If you look where it says control cycles, that basically indicates how many cycles it takes for the control algorithm to actually execute. Because it's an iterative algorithm, that value does vary. However, I have a limit on the number of iterations the algorithm takes. And if you're wondering why there's an iterative algorithm as part of the control algorithm, I'm basically using gradient descent to estimate certain parameters. I'm not going to really explain the math in this video since I'm pretty bad at explaining math in a video. I can be fairly incoherent, and I have a tendency to go off and ramble. So instead I actually made a blog which basically explains everything. But you'll find the link down below, and that basically concludes this video. My next step is to get the motors working. Well, before that, I need to figure out the best way of converting basically my angular velocity, which is related to the theta degrees, is proportionally related, and I need to convert that essentially to tangential speed, I believe, and then from there I can derive numbers to send to the motors. But that's the next step. Once I get all the pieces of the puzzle working, I'll begin to optimize. And that basically concludes this video. Thank you for those who are watching. Bye.